Alright, in this video I'm going to show you how to use a couple of functions that correspond to our Chapter 4 on probability. We're going to learn how to use if statements, CountIF statements, and we're going to learn how to create pivot tables for calculation of basic probabilities. So in this video we're starting again with a generic data set where we have the return on a particular stock in percent change. Okay, so we can interpret this as a reduction of 1.76% or an increase, in this case, of 2.14% of a particular stock price. What we're interested in this example is calculating the probability of seeing the stock fall by more than 1% or finding a loss of at least 1%. So we're going to do this in a couple of steps. The first thing we're going to do is we're going to think about defining a random variable x to be a variable that is discrete. It's either 0 or 1. We observe something that occurs or it doesn't. And in this case, the thing that occurs or it doesn't is the event of interest. Okay, and this event is the loss of at least 1%. So our end goal here is to calculate the probability that our random variable, okay, falls at least 1%. Okay, and in this case, the random variable is the percent change in our stock price. So what I've done here is I've gone through this and coded this manually. Now, the reason I'm going to code this as a series of zeros and ones, these zeros correspond to incidents where the stock price does not fall by 1%, and the ones correspond to places where it does fall by 1%. The reason I code it this way is because in a large set of data, then it becomes a very simple matter of figuring out how many ones there are, and if there are only zeros and ones as options, we could simply add up the entire column C, and we know how to do that saying equals sum, left parenthesis, $C colon $C, right parenthesis, and it would count those up for us. So let's go ahead and do that now. Equals sum, $C to $C, and we're going to get 8 events. Okay, so we're going to think about coding things in terms of zeros and ones because it will make the other functions we have far more easy to work with. Now, if you didn't want to go through this and code this manually, because you could be dealing with a large data set, in our example with only 50 observations, it's really not a big deal to do this manually, but we can get better than this, okay? And the first way we're going to do this is learning a new function called if. And that function works like this. It's equals if, and then we type in a logical test. Now, if that test holds, Excel will report the value if true. And if it does not hold, it will report the value of false. So we need to write this logical test in terms of some other cell and record the value in our current column B. So I'm going to say if A3 is less than or equal to -1. Put a 1 here, otherwise put a 0. Now notice what this is going to do is it's going to first look at each cell one at a time. The first thing it's going to do is look at cell A3 and say, is this less than -1? Since it's not, it's going to go, well, I need to put a 0 in this cell. So if we hit enter, that's what it's going to do. Now, again, we know we can click and drag this manually, or we can click and make that little crosshairs right on the bottom right-hand corner of that cell where the box shows up. Double clicking, it'll fill in all the way down. So again, we have zeros and ones that show up, but instead of having to do this manually, notice that our Excel function if says if A49 is less than or equal to -1, which it is, -1.1 is less than -1, put a 1 here, meaning we have observed the event we are interested in, and so to estimate the probability, we're going to add up the number of events we observe this for, and then divide it by the total number of events. So we're going to do it in 2 ways. I need to just add up the number of events, and we said we can do this using the sum function. So sum $B to $B. There are 8 events where we observe this. How many total events are there? There's 50. That means we can estimate this probability by dividing F3 by G3, and we get 16%. There's another option here, which is the CountIF function, and we can say equals CountIF. Now, it's going to ask us for a range. Now, unlike the if function, which works one cell at a time, The CountIF function works on an entire range of data and looks for how often a particular criteria happens. So in this case, I can say CountIF $A to $A, which means if anything in that column A has a particular criteria. Now, the criteria here have to be written in quotations. It's just a matter of syntax for Excel to let it know this is what we're looking for. So what I'm going to say is if anything in the range of column A is less than or equal to -1, I want you to count it up for me. So when we hit enter here, it's going to give us the same value 8 that we got before. So no matter how we choose to do this, we can estimate this probability by using the if or the CountIF or manually counting it if we really want to. But these are two new functions that will make much of what we're going to do later in the semester pretty useful. As we move on to the shirt sales tab, we're asked to calculate a variety of probabilities here. So we've defined event A. Let me write this out here for us. A is we are dealing with a red shirt, and B is we spent $25.